Hi, in this video, we're going to talk about the string pool in the Java language. Let's get started. So we're looking here at a very simple Java application that will help us demonstrate one aspect of the string pool in Java. I'm looking at a S1 string is pointing to the Java object, and S2 is pointing to the concatenation between ja and va. And then I've got a print statement that's going to do the equality operator on the two. Excuse me, this was from earlier. So I'm going to hit run and I'm going to get true. Now, you're told when you're comparing objects that you shouldn't use, in the Java language at least, that you shouldn't use the equal operator. And for a good reason. And we're going to get to that reason in a bit in this video. But let me just add few more cases here. So string S3, and I'm going to say new string Java, and I'm going to do S4, and I'm going to do, the same string concatenation that we had here. So what if I compare S3 and S4? What's going to happen? I'm going to get false. So basically, if you're creating strings, literal strings, as in you're not doing it the whole, because in Java you want to create everything as an object, right? Except for primitive types. But string is not a primitive type. So when you're doing this, it's really, you're creating an object of type string. It's just you're not explicitly creating it in your code. But that doesn't answer the question why S1 is equal to S2 and S3 is not equal to S4. You need to understand, to answer the question, what is actually being stored in S1 and S2 and S3 and S4. Because in Java, unless it's a primitive type, you know, the int, the float, character, etc., unless it's a primitive type, and we've 8 of those, you're not storing the actual value of the object inside the variable. You're storing a pointer to the memory location in the heap where that object is being instantiated and created. So let me get some diagrams to help illustrate this idea. So before we go to the diagrams on the iPad, I wanted to show you those 3 lines that I want to add that I think will help demonstrate the point that I'm trying to make. So S5 Java, just as this one. This one is the same, but the J is lowercase. And this one is just Python. So adding 3 more strings, I'm going to take a snapshot of this application, and we're going to look at it, and we're going to see how those variables are being represented in memory. Okay, so let me make sure the iPad works. Yeah, it does. Right, so this is the place, the Java heap, the place where all the objects that the Java program creates are stored, maintained, mutated, and then deleted, and shared between threads. The Java heap. And inside the Java heap, we have a very special pool of objects called the string pool. Right, now, I want to talk about what happens when you create a string. There are 2 ways to create a string. One would be to use a literal string, like what we're looking at here, Java, that's a string, Java, anything really between the quotations. This is a literal string, both are literal strings, literal string, literal string, literal string, etc. Now, although this takes in as an argument a literal string, it does create an object of type string. So this creates an object of type string as well. It's just the place where this and this and this is created is in the string pool, where the object new string is created outside of this string pool, is created somewhere here. Does that make sense? Okay, so why do we need the string pool? Why can't we just create all objects over here, like in this area? And the answer is, the most interesting answer is for basically saving space. So notice how many times I've duplicated this Java, Java, Java. In your Java application, especially if it gets a little more complicated than this, you're going to have instances where the same string is being created over and over and over. And so to basically optimize around that issue, instead of storing Java, Java, Java like a million times, you could store one object, Java, and have you could have a million references, as in what you store in the variable here, you're not actually storing, unless you have a primitive data type, integer, float, you're not storing the actual object here, you're storing a reference. So let's look at this first line, line number 1. We have a string s1 equals Java. So the Java language is saying, oh, I have to create a new object of type string in memory. I have two choices. I either create it in the string pool or in the Java heap. I'm going to create it in the Java heap. So I'm going to create it in the string pool. Why? Because it's a literal string. So I'm going to create Java, and that's in a box, indicating that that is a Java object of type string. I'm going to give it a memory location, and excuse my dumb numbers, just for the sake of simplicity, I'm going to give it the number 30, okay? And so the number 30 is stored here. So effectively, you have S1 pointing here, okay? Now, I'm going to leave S2 for a little bit. I'm not going to talk about it. I'm going to jump to this line. So that's line 2, 3, 4, 5, 6, 7. So I'm going to jump to line number 5. And I have S5. S5 is also pointing to the same object. Why? Because it is the same thing. So you see the power of the string pool. Now, I don't have to do another object, Java, and give it address 31 and then assign 31 here. No, I don't have to do any of that. I could just say, oh, S5 is also pointing to Java, location number 30. So this will have 30 stored in it. So if I say system.out.println and I compare S5 and S1, I'm going to get S1 equal S5, I'm going to get true. Why? Because they both have the value 30 in them. Does that make sense? Now, I have S6. S6 is another string that looks similar, but is really not similar because the first letter is different. So the whole string is different. So what we're going to have to do is we're going to have to create another one in location 31, and then we're going to give the value 31 to S6. So S6 is pointing to location 31. It's a small lowercase. So S7 is a completely different string. So I'm going to store Python in location 32, and that's going to be pointed out by S7. So 32. So when you say something like system.out.println, say S6 and S5. Now S6 is pointing to location 31. S6 has 31 stored in it, and S5 has 30 stored in it. So when you compare 30 and 31, it's a completely different location, so you're going to get false. All right, so we understand why, and if we actually go back to the code, allow me to just get rid of this for a second. Let me just show you this in the code. So I'm going to comment these out, S out, S5. We're going to start S5 equal S1, and that's going to be true because we're comparing Java and Java. Now S5 equal S6. Now that's going to be false because they're completely different objects. Going back to my tablet. Where's my pen? Right. So what happens here in those lines 3 and 4? What is actually happening? You're creating a new object of type string outside the Java string pool, but still inside the heap. So really, anywhere here, you're creating it. So let's create S3. So S3 needs to create Java in the string pool first, and then pass it on to the constructor of string, and then create the new, and then create the, I should use the pointer and the iPad. And then this will create the new string over here, right? So let's do that. Let's say that location 10, there is an object, and that object will be Java, and it will be the new string 1, right? So in the S3, I'm going to store 10. So S3 points at this one, which used this one in its creation, if you remember, over here. So the value stored in S3 is 10. So when we do compare S1 and S3, you're really comparing 30 versus 10, and you're getting false. And then when you create another object again, S4, you're creating another object here that has the address 11, and in that there is also Java as well, okay? So that's going to be address 11. So if you compare 3 and 4, you're going to get false. If you compare S3 and S1, you're going to get false. If you compare S4 and S1, you're going to get false. So you get the point. Now back to the initial code that we started with, which is comparing those two. If you recall, we had S1 equal S2, and that was true, right? So what is actually happening here? Why are we getting true? For obviously, you should have something like this, ja and va. Why don't we have those and then having them combined into this? Like, why isn't this happening? And the reason why it's not happening is because the Java compiler, when you compile your code, will look at things that it can optimize, and it will see that, oh, this is a literal string and this is a literal string. So I don't have to create two literal strings in the string pool because they're going to be combined. So I can combine them and then create that literal string in the pool. So if you don't believe me, we can do something called S1 equal S2. We can decompile our executable, our bytecode. So the bytecode, if you're using IntelliJ, is stored in target classes. You know, it's a Maven-based project. Now that's a class file, and you can double click it and it will show you main.class. So we were working with main.java. It's going to show you main.class. And notice the difference between the two, right? So comparing the two, I'm going to see that the same class name, there is a constructor added where this one doesn't have a constructor. And then I see S1 is unchanged, but S2 was optimized by the compiler to become just Java, okay? So that is why when going back here, I have two lines that have the same literal string, Java, Java. They would end up pointing to the same location in the string pool. And that's exactly what's happening here. And that's why we're getting true when we're comparing S1 and S2. Now you may be wondering, okay, I understand what you're talking about and it makes sense, but how do I see it? Like, how do I know that any of the stuff is actually true? And how do I verify it? And the answer is Java profiling. So I use Visual VM because it's free, really, and it's pretty good to profile my Java applications. So what I'm going to do is I'm going to modify this application just a little bit, and I'm going to take a snapshot of its heap and look at it. And we can see those variables being created and stored in the heap, in whether it's in the string pool or outside the string pool. We have a new program now that's been modified, and it's got S1, S2, S3, basically pointing to the same object that's going to be stored in a string pool. And then S4 will also point to the same object because it's a concatenation of both. Let's just give it a quick run and decompile, and you can see they're all the same. Now, except for S5, of course, which is pointing to an object that will be created in the heap outside the pool. And then I've just added those two lines, this line for us to have a breakpoint, and So we want to use a Java profiler and do a heap dump. And so we want the application to be running. If I just run the application, it's going to terminate very quickly. And I don't want that. So I'm going to run it in debug mode, and I'm going to make sure it's just pausing the thread that we're working with. As you know, an application will have many threads. So I'd like the other threads to be functional. And just a printout statement to make sure that those values or those objects are not being collected by the garbage collector. Right, let's fire up Visual VM and connect to main, our process. So I'll just look for it, and there it is. That's the process. I can connect to it by double clicking, and it'll just take some time to load up the connection. And as you can see, we're connected. What we're interested to do in this exercise is, in the sampler, we want to look at a sample of what the memory looks like. So when you hit memory over here, you have a heap histogram, which is basically showing you all the objects that are in memory that your application is maintaining. And it refreshes every few seconds. And what we're looking at here is, I guess not every few seconds, every 1 second. Sorry about that. And what we're interested to find is the objects that are of type java.lang.string. And right now we have 28,000 of them. So this is not very, like, this is changing. So I want to have a one snapshot, like take a sample, a snapshot in time. And to do that, I can perform a heap dump. And so to do that, I'll just click this button and notice what's going to happen here. So I've taken the heap dump and I can see it over here. So I can just right click and save it. So I'll have that file for my, I can save it and store it for my records to look at what the memory looked like at the time of taking that snapshot. I'll just save it because we're going to use IntelliJ in a bit to look at the content of it. All right, so we're back in IntelliJ, and this time I'm going to open the Profiler tool window. And instead of having IntelliJ profile the process for me, I'm just going to head over to Open Snapshot. And I'm going to select the snapshot that we've just created. And notice that it has loaded a list of all the objects that are inside that snapshot, that were basically inside the memory, inside the heap at the time of taking the snapshot. And what I'm really interested in is that category, the java.lang.string. So double click it, and it will show you the whatever 28,000, I don't remember the number, that we had in the memory. And then look, big integer, whatever, module not found, required, all sorts of strings that you can find in here. And so what we're really interested in looking for is this one. So we can hit the, and this is where IntelliJ's inspector allows me to search where the Visual VM doesn't. And I'm going to search for, this is a test. And notice it found two objects, right? Those two objects are exactly the same in the sense that they store the same value, but they do have a very fundamental difference, the two objects. And if you read between the lines, you will see that this one belongs to the global JNI, the Java native interface. So this one is a global object. And it would make sense for an object in the pool to be global, because if you want to reuse the same string across your application, it makes sense for any reference to that object anywhere in your application to be able to point to it. Whereas this one belongs to a Java frame. Now, what is a Java frame? Inside each thread, actually, we have the debugger here open so you can see. So this is a thread, right? It's called the main thread. And inside it, there will be a bunch of frames. So we have one frame only, like you can see, switch frames from anywhere, blah, blah, blah. So, all right, let's say that I put a breakpoint here, right? And I hit F9. Then that's one frame, and then that's the next frame. So the call stack, each method call is a frame. So distracting myself. Going back here, this one belongs to the frame org.example.main.main. Keeps running away from me. You can see it here, .main.main. Now what that means is once you exit the frame, the garbage collector is going to be like, okay, that object is not accessible anywhere because it was created within this scope or frame. And once you leave that frame, it's no longer required. So it's going to collect it. Make sense? So that's the distinction between the two. I hope that makes sense. Thank you for watching, and I hope you learned something, and I will see you in the next one. Bye.